Hello, everyone.
Hello.
We'll give 2-3 minutes to others to join us, expecting more.
Hey, Professor Matt Wally, I had a quick question.
Yes, sir.
So in topic 3, for the responding to sensor input, the assignment just says to submit code, but you don't actually have anything in the assignment page or the syllabus for what we're supposed to do regarding that. Like, I guess, what are you looking for that part?
Would you share the screen and show me what you are asking about?
Yeah. So this is for topic 3, but the responding to the sensor input, you kind of just like describe the background and then you just say submit a copy of code.
Just on it. Let me read it. I'll be back in a second. Just give me. Would you please stop sharing and let me share the screen?
Yep. Okay.
Do you remember this?
Yes, I do.
This is an example. You can submit this one. Responding to a user input. The user input here is pressing the buttons And I have seen this from almost all of you running and perfect. So all what you need to do is submit the code and a link to small video where the tone is changing.
Okay.
Okay. Now, let me speak about our program for tonight. We have two topics that we are going to go over. I am going to give you the last in-class activity of our topic 3. Then we are going to discuss your projects. Your projects are due a week from tonight. That means next week you will be with your partner presenting your project and uploading it. So tonight you will be presenting your idea, you and your partner, and you tell me what you are going to do to see if it is good enough or we need to upgrade it a little, or if it is too much, I'll tell you it is too much. So we'll discuss that. But our first item of business is to see the last in-class activity. I believe you started this last time. You managed to read the light intensity. Here, I want you to read 100 reading and give 1 second in between or half a second in between each reading and the other. Get the average. If the average is below certain limit, too dark, for example, you will send a message. Okay? So this is our assignment that I want you to do. And I'll give you about half an hour for it. Please read. If you have any question, let me know. Do you need me to keep this?
Yes, if you could, please.
I'll do something better. I'll send it to you as an announcement.
There we go.
Can you see my announcement?
Yes, it's there.
Okay, great.
Thank you.
Go ahead. And I'm not sharing the screen. You can discuss it together. You can share the screen, whatever you like. Hello, Eric.
Hello there.
Are you ready?
Sure.
Go ahead.
Okay, let's see. Share screen. All right, here's mine. I just started by defining some things for my light sensor and number of samples and my LED, declaring some variables that I'll use throughout. Then I move into setup, declaring the LED as an output, beginning my serial and all that. So my main loop, each time it restarts, it sets my average back down to 0. Then I have a for loop that will collect all the samples of light for 100 samples. The number of samples is 100. It collects all those values, puts them into the array. And then once that's collected 100 samples, I'll find the average and print that out. And then I have an if statement that will turn the built-in LED on if the light is below the threshold. And then I also had it for debugging, just letting me know it's below the minimum there. And yeah, so it will keep the built-in LED on. It will be high until the next average is below the threshold. Any questions?
Yes, sir. Can you run it now?
Yeah. It's, let me see if I can. Where's my Zoom? Oh, stop sharing. And then camera. You can see that. So the LED will light up if it is below the threshold. And if I turn a light on and it collects some samples, then it will let's collect some samples. And then it will turn the LED off once its average from the samples are beyond the threshold.
Great. Thank you, sir.
Welcome.
Brandon? Hello, Brandon.
Hello.
Are you ready?
Yep.
Okay. Go ahead, please.
So this is my code. Just defining a constant for the number of samples, then creating an array to store them in. Setting the LED as an output and the light sensor as an input. Then just going through and reading them all and then summing them up value by value, and then using a variable average to convert them to an average. Then we print that. And then I just said if it's less than 1, then turn the LED high. And if it's low, if it's more than that, then turn it low. So I have it running now. I can share my screen. I don't know if you can see me, but so yeah, so if I cover it. And that's it.
Would you run it?
Yeah, I just did. You want me to show it again? Okay, so it's running now. But so if I cover the sensor, then it turns on. Yeah, I probably should have set it higher, but yeah, I think I need to set it higher, but you can see it's kind of blinking intermittently. And then if I take my finger off, it doesn't blink at all.
Okay. Thank you very much. Arturo?
Yes, I'm still working on it. Can you give me 10 more minutes?
Ben? Hello, Ben?
Oh, hi. Hi.
Ready?
Sure. Let me see if I can find it here real quick. Light sensor. Okay, so here is my code. Okay, so I kind of have it running right now. But okay, so I just kind of set up the light sensor and then the analog to digital converter, then LED 13. Had a light array, moving average array, and a low value for the float to turn on the signal. And then I just kind of added to this other light sensor app that we had before. I just added a digital write to turn it off. And then if the average gets to that low, if it goes below the low, then I turn the light on. And if I get back over here to the camera, just a second here. Oh wait, I gotta stop share, don't I? Okay, and then I can turn on my camera. And okay, so right now it's off because there's some light shining on it. But if I put my hand over the sensor, the light comes on and it'll shut off after it takes enough samples to move the average down.
Thank you, great. I believe it's now time for the presentation, the project presentation. Whoever is ready is welcome to share with us his ideas.
Me and Ben are, we're not really ready for. We don't have any like slides prepared, but we have the concept and some working prototype code.
Okay.
So what we're trying to do is we're using the neopixels and the light sensor to measure.
Who is your partners?
My partner is Ben.
It's me, Benjamin Schroeder.
Okay.
Yeah, so we're measuring the color of an object in front of the board by using the neopixels in red, green, and blue, and then measuring the reflected light off of the object in front of it.
So if you shine the red light on a red object, it'll generate a higher voltage into the sensor. If you shine a red light on a blue object, it'll have a less voltage, or on a green object, it'll do a less voltage. And then we'll turn on the green lights and do the same sort of comparisons, then turn the blue lights on, do another set of comparisons, and then that'll give us an idea of what the color was that it was presented with.
Very good.
Yeah, we have proof of concept code that works pretty good. Decent dynamic range.
Yeah. And you're going to take one reading and decide, or you're going to get more than one reading and decide?
We're taking a whole bunch of readings, and then we're going to do some processing to just make sure that we have a confident result, and then we're going to print out the color it thinks it is.
Yeah. Because you see, you might get a spike of light due to anything. And if you can get the average, that would diminish the effect of the spike.
Right. Yeah, that's why we're taking it over a period of time. We also have a calibration pass with just white light first, just to make sure that all the ranges are fit.
Okay.
And we also may isolate the whole apparatus into a little box so that it's only looking at the light in front of it.
What will be your output?
Our output will be a RGB color value and also a string that is the color it expects. So like yellow, red, magenta, whatever. We're gonna try to we're gonna try to classify the color as well.
So you are gonna transfer that to one of the new lines.
We might try to get it into a NeoPixel.
Okay.
It may be a hard translation.
Yeah,
Okay.
that wouldn't be super hard. It's just that was kind of a weird thing to do because you're already probably covering the entire object with it. But that's cool. That's a cool idea. We
The
might do
color
that.
has been transferred to a number. You are getting the color and it is a number now.
Yeah, no,
you
it
can
wouldn't be hard to do
this
that.
number to new pixel.
Okay, well, we can do that. Yeah,
Okay.
sure. That's like 2 more lines of code. We can do that.
Yeah, because it is. If you give me a number, I don't know what this number is. But if you verify it by giving the same color to the new pixel, that's great.
Right, and that's on top of us on the serial port printing out like the name like red, and for example.
Okay. Thank you, sir.
Uh-huh.
Next. No one else?
Well, the 2 people that I had chatted with in the announcements, Brendan Dickerson and Benjamin Mai, they're not in class, so
Can you speak for them?
we haven't gotten to discussing, but one thing I'm interested in playing with is getting values from the accelerometer on the board and lighting up the NeoPixel LEDs based on the orientation of the board. So if you tilt the board one direction, like a sort of like a digital level, you know, so like a plumb bob, you know. So if the board is tilted one direction, the LEDs on the bottom will be lit up, and if you tilt it the other way, it changes the LEDs that are lighting up.
Again, you need to get some average.
Correct. Absolutely. Yeah, it'd be you'd have to average out the data from the accelerometer, and then also put that into another function that will, you know, or another part of the code that will light up the appropriate LEDs. But like I said, I haven't the others in my group are not present, or we haven't had much discussion, so we'll see how that goes.
Would you please add to it fast move? I get a siren.
Can you repeat that, please?
For fast moving. If there is a fast movement, I get a siren, some sound, alarming sound.
Yeah, honestly, yeah, absolutely. That wouldn't be. That seems plausible.
Okay. How many are you? 3?
Right, yeah, that was a proposal of 3. Brendan Dickerson had responded saying we'll be in a group, and then I proposed that Benjamin Mai was looking for a partner or for a group, so I was proposing a group of 3.
Okay. So far we have 5. Any more presentations?
Yeah, I'm in a group with Brandon. So we have this idea. I don't know if you want to put this to, if you think it's something a little bit difficult out of the way. We're thinking of using the speaker and the pixels and NeoPixels to give the user an option to play either a song, like a Christmas song or like a Halloween song, and then pick it and then use a speaker to play the song and display some lights according to the theme.
Oh, that would be great. Yep.
Okay, good.
Excellent.
Do you have enough RAM in the microcontroller to hold all that?
I don't know, man. We'll find out, I guess.
I have some like some microcontrollers with more storage that we can use too, besides the NeoPixel or the circuit playground.
Okay. Any more ideas? For those who didn't present any idea, they can send me an email with their idea so I can tune it for them. Because a week from today, you will be presenting your project. And if you present a project that I didn't approve and I think it is not good enough, you will lose the grade. So please try to get my approval well ahead of time. Okay? Those who didn't present any ideas so far. We'll stop at this point and I will let you work together on the project. And hopefully we'll see great projects on Thursday. Any questions? Okay, I wish you a great evening and see you in a week from today.
Okay,
Bye
see
now.
you then.
Thank
Have a
you.
good
Bye-bye.
evening, everybody.
Have a good night. Bye.
Bye-bye.